Here is called this is angle, what is this called? This is called central angles and circles and their properties. So this thing, angle ABC, is called a central angle. And a central angle is an angle with its vertex at the center of the circle. And if this is 50 degrees here, for instance, then this arc AC is also 50 degrees. So the measure of, so on your conjecture sheet, that first one, it should say if two, oh, that's not what I'm looking for. So the measure of, wait, no, it doesn't really say this anymore. But the measure of a central angle is equal to the measure of, this is called an intercepted arc. Intercepted arc, which is the arc that the radii kind of cut off, or that angle cuts off. So the measure of angle ABC is equal to 50 degrees, but also the measure of arc AC, and you put a little curvy bracket on top of it, is also equal to 50 degrees. Okay? So the measure of an arc, when you talk about the measure of arc, you're talking about how much of the circle it is. You're not talking about how far it is from here to here. That's something different. That's called arc length. Okay?
Wait, so it's not like percentage?
It's kind of like percent. Well, it's 53/60ths of the circle, right? But the measure of the arc is 50 degrees. So what would be the measure of, say this is x over here, what would be the measure of arc AX be? We already did ones like this. That would be 310, and then
So it is
310, right?
Oh no, it's just out of.
310 degrees. Yeah, so the measure of the arc is the same as the measure of this angle right there. So it doesn't matter if I were to make this circle smaller, the measure of the arc wouldn't change, right? So look, if I were to take, I can do this using my high-tech tools. Watch this. Say, we're to take this, and say I were to make it smaller. Oh! Let's undo that. Undo.
You have to group it all first.
Okay. So didn't I just group? Oh, you have to edit, make group. So if I squished everything, right, it would still be 50 degrees in measure of the arc. Okay. So your first conjecture says chord central angle conjecture. If two chords in a circle are congruent, then they determine two. I'm going to bring this up on my website as well. Okay. I'm going to go here and in my Dropbox. So right there. I'm going to go to Geometry Advanced. I'm going to go to Chapter 6. I'm going to go to Chapter 6 Conjectures. Wow. Look at that. So it turns out that chord central angle, if two chords in a circle are congruent, then they determine two central angles that are also congruent. So if I were to draw two circles, come on, why did it do that?
I don't know.
I don't know. So if I were to draw two circles on here in this little picture, correcting.
That was not me.
Who was that?
That was Brandon.
So if I were to draw a chord from here to here, and another chord from here to here, and if I tell you that these two chords are congruent, if this is congruent to this, then it turns out that if I were to draw another circle from here, okay, like that, it turns out that these angles, how do I draw? This is kind of complicated. That this and this is not going to be exactly the same. And these angles right here, oops, I'm going too fast.
Oh, I got you.
Okay, it turns out that these two angles in red are also tell me why that would be true? No, not alternate interiors. But if this is congruent to this,
CPC.
this is congruent to this, because these are all radii, right? And all radii are the same. Then these triangles have to be congruent, therefore those angles have to be. Okay? So that says if two chords in a circle are congruent, then they determine two central angles that are congruent. And you can just write like that. Chord arcs conjecture. If two chords are in a circle are congruent, then their intercepted arcs are hello. Parallel arcs congruent. So in other words, if I have two, so if you kind of extend this a little bit, okay? If these are congruent and these angles are congruent, right? What has to be true about this arc here and this arc here? They have to be congruent as well because the angle determines the measure of that arc, right? And so you could draw a little picture of that. I'm going to just try to use my tools to, I'll just, chords arc, if two chords in a circle, then I'm going to try to draw freehand. Can I do that? Not very well. Yeah. So if these are congruent,
A for effort.
okay, then these two chords over here and here are congruent. So these are congruent to that. You understand what I just did?
Yeah.
Are you writing this down, Brecken?
Yes, I am.
I would suggest it. Good.
Swear.
All right. So, next one. Perpendicular to a chord conjecture. The perpendicular. Oh, this is an interesting one. Okay. So I was going to do this on Sketchpad and stuff, but
I
since
don't
we
think
don't
you
have
should read it so fast.
we don't have time. Let me make this a little bit bigger. Okay. So if I were going to draw a circle here, perpendicular to a chord, the perpendicular from the center to a chord. So here is a circle. Here is a chord. And if I were to make a perpendicular from this center to this chord, does that look perpendicular? More or less.
Yeah.
Guess what it does to that chord? What do you think, Sam? Very good. It bisects it. And there are reasons. If that's true, then what's got to be true is that it makes this, it cuts this chord into two
Parts.
congruent pieces. Got it? And the reason for that is, if you think about it, what's really going on here is I have some, see this and this? I would have congruent triangles, because if I know that this is perpendicular, it means both of those angles are congruent. This is congruent to itself. These are congruent to each other. And this would be side angle, which you probably say side angle is not a way to prove triangles are congruent, but if that is a right angle, there's something called hypotenuse leg, which does allow you to say that those triangles are congruent. But in any case, if it's perpendicular, then it cuts this segment in half. Questions on that so far? Okay. Next thing. What's what? Oh, what do I fill it in with? The perpendicular bisector from the center of the circle to the chord is the bisector of the chord. Right? Questions? Answers? All right. So next one. Next one says C56. Are we almost done? Did I do this one already? 57, right?
Yep.
Chord distance to the center, two congruents in this are, guess what? Should go there.
Congruent.
Nah.
Same as this.
Yes, same distance. Equidistant is the word you want to use. Equidistant from the center of the circle. So if I were to draw a circle, going to draw a circle here, and I were to draw two chords that are congruent. I don't want to make it solid. Two chords that are congruent. Not very good. But it turns out that these things, this would be a good thing to do in the lab, that the distance from here to here and the distance from here to here is the same. Okay? So these are the same distance, and remember distance is always measured perpendicular. So if these are the same, then they're the same distance away from the center of the circle. And that can be proved using congruent triangles. So that's probably not a very good picture. Because what I should have really done is that okay? You guys get that?
Yeah.
Let's just, if this is true, then, whoa, this thing doesn't draw very good circles when you're trying to do it freehand. If this is true, then this piece, that's not very good. Then that's got to be congruent to that. That might be a better way. That looks like a baseball, doesn't it? Sort of. Okay.
Okay.
And then the last one that you have on your conjecture sheet says that
Here, like,
perpendicular bisector of a chord, and this is an important one. Perpendicular bisector of a chord. The perpendicular bisector of a chord passes through the. Oh, you guys are smart. Let me just show you this. I'm going to do this on GST. Watch. Watch. Watch me go. For the viewing audience out there, I'm going to make a circle. Here's a circle. And I'm going to make a chord. I would use that other thing. Here's a chord. So we're going to make a chord on this circle. No, I want to get a chord. Why is it not there? Delete. Edit. It won't let me delete.
just like click the backspace
Right.
button.
This button.
Backspace. I don't know if you have a
Yeah.
backspace on your little keyboard.
Control Z.
Anyway,
Delete.
let's
Can you
just.
see this?
Just
I
like
can't
this.
see the screen. Let's just do this. So let's make a chord going
This
from
would be
here to here. Okay? And let's put a point.
Can you see what you're doing right?
Let's do this. And if I go, well, I'm getting confused with my multi-board tools and my sketch construct midpoint. Okay? And then if I go like this, boom, boom, and I say construct perpendicular line, notice that that perpendicular line goes through the center. And if I were to do that again somewhere else, I go over here, not necessarily the same length. Ups, and then want to do that.
Can you adjust it?
Can I adjust it? No.
With the mouse.
Hey, can I do it? No, it won't let, once it's there, it's there. Let's try that again. So if I do it again, make another chord like here, here. Okay? And then I put a point on the midpoint. Construct midpoint. So like this.
So I'm not dying.
Construct perpendicular
Thank the
line.
Lord.
Notice that both of these go through the center of the circle, right?
Sick.
So when if I were to drag this around or drag these chords around, notice that the perpendicular bisector of any chord that you make in a circle always goes through the center of the circle. And that's very useful if you want to locate the center of a circle. So you'll have some problems like this. They'll say, so what they'll do, watch, they'll say, new sketch. They'll say, find the center of this circle. And you go, oh, there it is. But no, that's not the way you do it. It gives it to me. But all I'd have to do is, let's do it a little bit differently. So say you have a circle. Where's circle? Circle here. Circle there. And they say find the center. Okay? And the way you find the center is by making a chord. So making one chord. And then do the perpendicular bisector to that chord. So you can construct it using your compass and straight edge. And you know that somewhere on there it goes to the center. How do you know where the center is? You have to do it. You have to have at least two chords, right? And where they intersect. So if I were to do another chord from here to here, and then do the perpendicular bisector of that one, then you can figure out that that's got to be the center of the chord.
Oh, that's
Get that?
pretty good. It's pretty accurate.
It's pretty accurate. It's just a lucky get. So then I have a couple examples, and then we're going to be done.
What's the word for that?
The word. What's the word? Oh, center. The word.
Duh.
Word. What? Oh, word. You weren't just saying that's word means that's cool, right? Or something like that. So the word that goes here is center. Center of the circle. And then I have two more example problems for you, and then we'll be done. So, say for instance, I had something that looks like a circle. I'm just going to give you one example because this is about as confusing as they get. So say I have something that looks like a circle, and then I have a chord over here that looks like this, and then I have a chord over here that looks like this, and then I give you that this is 100 degrees from here to here, okay, from here to here, and then say all I tell you is that this is congruent to this, and they put something over here, and let's say that this is 80 degrees. How could that be 80 degrees? Let's say it's not to scale. Let's say this is 110 degrees. That couldn't be 100 degrees, could it? Let's make this be like 50 over here. And then they want to know what is this arc over here. Could you do that?
Yeah.
If this is 110, what does this have to be over here? 110. How many degrees in a circle? 360. So that's 110 plus 110, which is 220 plus 60 is 270, right? So how much does this have to be? 90 degrees. Okay? So you'll have some problems that kind of look. They ask you to kind of think a little bit. And that's kind of it. Okay? So your homework for tonight is page 310. Whoa. 1 through 11. 13. 15. 16 and 17. Not too bad. Right? The end. And remember, you heard it here on roller derby.